Welcome to the 5 exponential laws tutorials. So we will be dealing with the introduction to these 5 exponential laws, but before we get down to it, we need to just understand some few concepts when it comes to exponents. All right, so when you multiply a number, for example, if you had 2 times 2 times 2. All right, so this can be rewritten as 2 to the exponent of 3. All right, so you need to know that the concept around the number at the bottom and the little number at the top. So the number at the bottom is what we refer to as the base, right? Base. Right, kind of think of it maybe as like a house. So you would have the base of the house being at the bottom, and the number at the top, right, is therefore called an exponent. Exponent. Right, and together these two are called a power. Okay. All right. So if you understand these concepts, then you will be able to understand our exponential laws. All right, so let's get down to our first exponential law. All right, so law number one. Law number one is called the product rule, and what it states is that when multiplying powers, okay, when multiplying powers of the same base, add the exponents. Okay, so consider you have maybe a certain number that we will call a. So remember, we use variable to represent any type of number. It could be 1, 2, 3, 4, or 1,000, a million, could be any number. So we just use that letter to represent that. So if you have any number, maybe with for example a, with any exponent, for example maybe n, multiplied by another number with the same base like itself, but maybe with a different exponent, maybe let's say this time m, right? This means that you are going to just write the base itself, right, alone, and then you add the exponent. So in this case it would be n plus m. So this is gonna be your law. All right, what this means is, for example, what I did there when I said 2 times 2 times 2 is equals to 2 to the exponent of 3. What happened is, when each 2 there, because there's no exponent written, has an exponent of 1, 2 to the exponent 1, and then when you multiply the 3 2's with an exponent of 1, you just add the exponent. So you said 2, this is equals to 2, 1 plus 1 plus 1, and therefore which was equals to 2 to the exponent of 3. All right, so now if you have maybe a number 2 to the exponent of 4 times 2 to the exponent of 3, right, you can rewrite this as 2 to the exponent of 4 plus 3, because they have the same base, so you can add the exponent, and this will be equivalent to 2 to the exponent of 7. Okay, so at times you have even more numbers. For example, so you might have 3 to the exponent of 1 times 3 to the exponent of 4 times 3 to the exponent of 5, maybe times 3 to the exponent of 2. All right, then this is going to give you, you just write only 3 because all of them are powers with the same base, and the base is 3. So you write the base first, then you add the exponent. Okay, so on the first 3 there's no exponent, which means its exponent is 1. So it's going to be 1 plus 4 plus 5, then plus 2, and then all together you say 1 plus 4 is 5, plus 5 is 10, then plus 2 is going to be 12. So this is going to be 3 to the exponent of 12. All right, I hope that's understood there. So you can do this also if you have your variables. Right, so let's say you have x to the exponent of 2 times x to the exponent of 4. This will equals to same base, base is x, exponents are 2 plus 4, which gives you x to the exponent of 6. All right, so let's look at now law number 2. Right, so law number 2 is called the quotient rule, right, which says when dividing powers of the same base, subtract the exponent. I hope you remember what powers means and what exponent means. So a power is any number that has an exponent. Okay, so here it's saying that if you are dividing any number that has an exponent, well, numbers always have an exponent, it just depends on what that exponent is. So when dividing any number with an exponent, and that number will be called a power, you need to subtract the exponent, right? What does that mean? So if you have a certain number a with an exponent maybe n, and you divide it by another number, right, which has the same base like itself, but maybe has a different exponent, the exponent m, this will equal to just the base a with subtraction of exponent. So it will be n minus m. So that's how we represent that mathematically. Okay. Right, so you can do that. So this means that if you have, for example, 2 to the exponent of 4 divided by 2 to the exponent of 2, the answer is going to be just base 2 with an exponent of 4 minus 2. The answer is going to be 2 to the exponent of 2. Then what if you have, for example, maybe 4 to the exponent of 3 divided by 4 to the exponent of 7. Right, what you're going to do is you're going to say this is equals to 4 to the exponent of 3 minus 7, and then you're going to get a negative exponent in this case, 4 to the negative of 4. Okay, so I would say that's example 1, example 2. But you can also have variables. Example, you might have x to the exponent of 8 divided by x to the exponent of 3. This will give rise to x to the exponent of 8 minus 3, and that is going to be x to the exponent of 5. Okay, so you might even have more numbers involved. So for example, you might have x exponent of 4 times y exponent of 3 divided by x to the exponent of 7, all right, and then y to the exponent of 2. Right, this will mean that you handle them separately. So in this case, you have two bases, so you're going to write those two bases. Right, it's going to be equals to base x times base y. All right, and then with x, you're going to subtract its exponent, 4 minus 7. And then with y, you're going to subtract its exponent, 3 minus 2, which will give rise to x to the exponent of minus 3 and y to the exponent of 1. And since it's the exponent of 1, I will not write anything there. All right. Now, this, you might have seen some negative exponents. We don't really prefer writing numbers with negative exponents in mathematics. So we have a law for all those negative exponents, right? So we call it the inverse rule. Okay, so what does it state? It says that any power with a negative exponent can be written can be written as an inverse. Okay, can be written as an inverse of itself with a positive exponent. Okay, so maybe you might be wondering what is these inverses. Okay, so for example, if you write the number 2, right, any number can be rewritten as itself over an exponent of 1. So 2, its inverse will be 1 over 2. Right, so if you have 3, right, its inverse will be 1 over 3. Okay, so now with this law, it means that if you've got any number to an exponent of a negative, you can rewrite that as an inverse of itself, which will be 1 over itself to the positive exponent, like that. Okay, and the reverse could be the same. You might have 1 over an exponent of a negative. So what you will do is, right, you will write that as that number to the exponent of a positive over 1. All right, which is basically itself. Any number divided by 1 is itself. So basically this is just a to the n. We can look at some examples quickly. So example maybe will include, right, if you've got our numbers up there. So I think we had there some numbers that were, so for example, 4 to the exponent of minus 4 and the x to the minus 3 and y there. So I'm just going to copy those examples there. So if you've got 4 to the exponent of negative 4, you can rewrite this as 1 over 4 to the exponent of 4, positive 4. Okay, and then, so call this example 1. So, and then the other one, we had x to the negative 3, right, times y. So it means that this can be written as y will remain at the top, right? But then it's the same as saying y times 1 over x to the exponent of 3, which will give rise to y over x to the exponent of 3. So that's how we sort out all those negative exponents. And you might have, maybe for example, you might have x, okay, 1 over maybe let's just say letter a to the exponent of minus 3, right? This will mean that you can rewrite that as a to the exponent of positive 3. Right. Let's move to the next law. Right. The fourth law is called the zeroth rule, which says that any power with an exponent of 0 equals to the value of 1. So this means that if you got any number, right, a with an exponent of 0, that is equal to the value of 1. All right. So which means if you've got 2 to the exponent of 0, that's equal to the value of 1. Okay, if you got 100 to the exponent of 0, that equals 1. Right, if you've got x to the exponent of 0, that equals to 1. If you've got y, x, all of them to the exponent of 0, that equals to 1. Right, so it just doesn't matter what number you have, as long as it's to the exponent of 0, that's equal to 1. And then again, it means that any 1 can be rewritten as any number to the exponent of 0. Right, for example, 1, you can say 1, you can write it as, for example, any number, so you can write it as x to the 0. You can take 1 and write it as 2 to the exponent of 0. All right, so you can imagine y 1 over 2, sorry, okay, right, y 1 over 2 is like that. So let's say maybe I'm gonna do this. Okay, so if you've got, for example, let's say 2 2 over 1, right? This can be rewritten as 2 to the exponent of 1 over 2 to the exponent of 0, which is 2 to the exponent of 1 minus 0, and this is equals to 2, right? So for that reason, that's why any number, when it's divided by 1, nothing changes. It remains itself because it's like that number to an exponent of 0. Right, then let's move to the last law. Okay, law of raising the power rule. All right, it states that the exponent outside the bracket multiplies the exponent of each power inside the bracket. Okay, what does this mean? It means that if you've got some number a with an exponent n, okay, and also some number b, right, multiplying some number maybe b, maybe with an exponent of, let's just say m, right, and then outside the bracket you have some exponent of, for example, let's just say exponent k, right? Then you are going to, that exponent is going to multiply each exponent, the exponent of each power inside. So how many powers do we have? We have 2 powers, and they've got different bases. So we're going to write our base a. So that means it's going to be n times k, and then times b, which had exponent of m, and that exponent m will also be multiplied by k. Right, let's run some few examples. Okay, so there we go. All right, so what, before we start anything, I would like us to know some other things. Okay, so if you've got a root, okay, it also falls under this. So if you got a root of specific numbers. For example, those numbers again. Let's say the exponent, I mean the not the exponent, but the root is some number k. This is means that you've got those numbers can be written like this as a b to the m. So a root means that an exponent or inverse exponent outside the bracket. So that's what it means. So this will obviously result you into a n. So let me do this. So it will result into a n over k times b m over k. So whenever you see a root number, it means that it's going to divide each exponent inside. Okay, so it's going to divide each exponent of the powers that you have. So now let's look at some examples. So if we've got 2 to the exponent of 2 and times 3 to the exponent of 4, all in bracket with an exponent of 3. This means that that equals to 2 exponent of 2 times 3, right, times 3 to the exponent of 4 times 3. Notice each one of them is being multiplied. So then you are going to have 2 to the exponent of 6 and 3 to the exponent of 12. So by doing that, you have raised the powers. Okay. Same way you might have x to the exponent of 3, and then you might have y to the exponent of 2, and then q to the exponent of, let's say, 1, like that. So, and you have an exponent maybe outside of 3. So what's going to happen, you are going to say, let me use a different number because I used 3 last time. So let me use a number 5 this time. So you're going to have x exponent of 3 times 5. Then y to the exponent of 2 also times 5. Then you are going to have q to the exponent of, no exponent written means it's 1 times 5. So this will result you into x exponent of 15, y exponent of 10, and then q exponent of 5. Right. And then if you've got something like this, square root of 2 to the exponent of 6, and then y to the exponent of 4, and it's a square root like that. When there's no number in the root, it means the root is 2. Okay, so this will give rise to 2 to the exponent of 6, y to the exponent of 4, but then 1 over 2. Please remember, if there is nothing there, it means the number is a 2 for the roots. Okay, so and this will obviously give rise to 2 to the exponent 6 over 2, right, times y exponent 4 over 2, which will give 2 exponent of 3 y exponent of 2. Again, you might have, for example, root like that. Let's say you've got 5 there, and then inside you've got x to the 15, then y to the 25, and then you've got q to the 10. So this is going to be, since now you know, basically it's going to be x to the 15 over 5, and then times y to the 25 over 5, and then q to the 10 over 5, which will give you x to the 3, y to the 5, and then q to the 2. So that's basically it with introduction to exponential laws. All right, if you had this video helped you, so give it a like and give it a subscribe so that you can see more videos. All right, and we are going to have another video where it's going to just show you application in a more complex questions. All right, please check it out.